Hello, friends. Welcome to the Codeberry Club. Today we are going to start a CTF competition, which will end on Monday. Also, today we will tell about CTF at all, about how to solve it, what kind of problems are there. Also, we will tell why we need it at all. Let me introduce men who take a part in such competition since 2006. Chief Software Engineer from EPAM, Konstantin Perikov. Konstantin will tell us about all aspects of CTF and competition like that. Before I give microphone to Konstantin, I'm going to remind that we have Telegram channel and YouTube channel. Please follow us, and you can find links in comments under the video. Now I give microphone to Konstantin.
Thank you, Andrei. Thank you. Yeah, that's right. And actually, I would just correct a little bit. So I think from 2006 or something, I started solving different other competitions, not only specifically CTF, but others like sports programming, ACM, ACPC, and stuff like this. But yeah, today we're going to talk about CTF and more CTF competitions. I'm not sure if I will be able to discuss and talk about every aspect of this competition, but I hope it will be enough for introduction, and it's going to help us and all of the listeners greatly to solve these competitions. So yeah. So basically, we're talking about CTF, how one could solve it, and yeah, after on, we're gonna start the competition. So once again, who am I? I'm Konstantin Perikov. I'm a chief software engineer at company EPAM. Basically, most of my time I'm working at a search competency head, where I'm leading a group of architects, engineers, doing any sorts of complicated search-related systems based on the open source and proprietary technologies such as Solr, Lucene, Elasticsearch, and many others. We try to apply as much as possible cutting-edge technologies and NLP approaches, mixing them with vector space databases and similar. Also, I'm very curious, and this is something I do maybe more at night, in AI and ML, especially if it's in conjunction with the search, even though I'm doing various other stuff as well. I like to contribute to the open source as much as possible, and generally I would recommend everybody to this. And this is the link to the GitHub, just in case you want to subscribe to myself. So what we're gonna do today, and apart from just competition, right? Because the competition gonna start as soon as the talk will be ending. But what we're gonna do today, we're gonna talk about CTF, like what is CTF, why it's called like this, what's the competition behind it, right? We're gonna discuss the basic, I must force here, like it's only basic categories of the task. We're not gonna go into all of the types of the tasks, the most common ones. We're gonna discuss who these competitions are for, why it's fun, why it's not maybe just for hackers and security engineers. Then we're going to take a look a little bit in the personal experience. Every week, basically, there are different CTF competitions, and usually, if time permits, I'm trying to participate in them as much as possible. And we're going to talk about some of the past examples, let's say maybe some of my favorite even examples, something very interesting. And yeah, at the end, we're going to have some time for question answering, and we're going to start with the competition as well. So what is basically CTF? And CTF is actually an acronym, right? And you could translate it as a capture the flag, right? So it's about capturing the flag. And yeah, probably you heard about capture the flag before. I've heard, for example, for the first time, maybe somewhere in the 90s, playing like Quake video game. And it was like a mode which, was called capture the flag, where basically some teams are grabbing the flags from the other teams. So basically, I think it's generally inspired by the modes like this, where you have like some different teams, and in security, very often we have like red and blue teams, defense and attack, and they're trying to steal the flags from each other. Today we're going to talk about more like a solo CTF competition, something where it's not like teams fighting, let's say, against each other, but rather it's participants against the organizers, right, to some extent. So yeah, so we're gonna try to get flags from us, from the organizers. Once again, there is some general and basic types of the tasks, and very often even like in a proper amateur or professional teams, there is a specialization. So for example, one person is specialized in one type of the task and in other. And this, of course, helps to have a diverse team and also to focus on the deeper areas. So let's take a look into general basic type of the tasks, and the one is forensics. Of course, it's named a little bit differently, but I think they all under umbrella of forensics. And here you could think about tasks, related to different file formats, internal structure of those, maybe application of steganography, right? So stegano is something where the message is rather hidden instead of being encoded, like in cryptography. And one of the oldest probably example of steganography is Rome Empire or Dead Days, basically. So when some armies want to send the secret message to the other army, but want to make sure that it's not going to be found by the spies or anything like this, they did sometimes very interesting things, like not just trying to hide the, let's say, message, maybe like a piece of paper somewhere in a sandal or something, but instead they do a tattoo of this message on this person's head. But first they shave the person's head, then they do the tattoo, and then of course the hairs just grow. And as soon as it grow, it's not that much visible. And if you're gonna be stalked by somebody, they're gonna search you, but they're not gonna find anything. They're not gonna find any sorts of paper or anything like this. So this is, let's say, one of the classical application of steganography. Another one would be hiding it somewhere in the text, in the different encodings, etc., etc. There is other subset of tasks, subcategory, which is under the world of crypto or cryptography. And this is basically a lot about like different vulnerabilities related to crypto or improper implementation of it. So one of the basic example would be somebody just encoded the messages and you try to decrypt them. And for example, they could use it in a wrong way, in a proper way. So you could think about like a one-time pad, like one-time password, right? So like the mechanism from cryptography is forcing people to use the new password all the time, right? So generally, example of the one-time passwords is like you have like a book of the passwords, and whenever you use it, you just immediately cross it. And the person who's receiving your messages on the other side have similar one-time pad with one-time passwords. So then this person could cross the passwords as well and use them to decrypt. For example, if it's a symmetric encoding. And yeah, so for example, improper implementation of one-time password would be just if the passwords would be reused. This way you could potentially have a vector of attack. Another subcategory of the task is related to web, and this is generally related to anything appearing on the websites, right? So you could think about any web vulnerabilities, something like OWASP top 10 vulnerabilities very, very much often. So you could think about like cross-site script execution, maybe default passwords being used for some of these systems, or directory traversals, for example. This could be all sorts of different ways how things could be done. Another aspect could be reverse engineering. So this is more about taking a binary and finding a hidden information there. So for example, some sort of vulnerabilities or any other related stuffs. And so you could think about like getting a binary byte file, right? And finding something here, maybe some hidden information, some passwords, some keys, some flags. Binary exploitation, I think very much close to the reverse engineering, but though not limited to this one. So you could think about how you could execute some sort of exploit based on some error in the system. So it could be heap manipulation, buffer overflow. Maybe it could be something even recent from the end of the last year, when there was a log4j issue, right, in the popular login framework. Basically, there was a vector of attack exploit, right, when you have ability to use some sort of LDAP to execute the code. Basically, stuff like this. And today, actually, if you're gonna take a look, we're gonna have, let's say, not all of the types of the task, but for sure we're gonna have something for more forensics kind of things, crypto, web, and a little bit of reverse engineering. Not sure about binary exploitation today, but still. And obviously, talking about all those type of tasks, you could think, hey, is it just for hackers? Maybe security paranoids, right? So why I should do something like this? And first of all, I would say that it's not only for security oriented people. I think general trend in the industry is that very often the specialized security people, security teams, are pretty much aware of these kind of things, right? Like SQL injection, for example. I know it's a very common example, but how much often we found the developers, for example, who didn't think about SQL injection or didn't think about any other vulnerabilities. I think this is why it's crucial for the developers, and especially for developers, to participate in those kind of things. Understanding the mindset of the hacker, for example, or security forensic specialist would make you a better developer person, right? So thinking as an attacker how they're going to exploit your web application, for example, would make you write more secure code by design. And I think in this 21st century, basically, the security aspects would be more important every day, right? And we see it from year to year how the security grows, right? All these issues that appears, Heartbleed, Log4j issues, and many other ones, they just appear all the time. And this is caused very often, by improper implementation, improper quality gates. So understanding those attack vectors could be also very important. And last but not least, it's fun, it's a competition after all. It's not something you do maybe for work every day, but rather something you could do outside to just, reboot yourself. So now let's take a look into some of my personal experience. I wouldn't call myself like a great CTF solver or something, but whenever I have time and when time permits, I usually try to participate in the competition, and I'm usually having fun, even when I'm not being able to solve it. So yeah, but let's take a look at some of the examples. And yeah, I'm gonna try to do what is called usually like a write-up. So I'm gonna explain how this could be solved. So I hope this could give you an intuition for some maybe of the tasks for today as well. Something to thinking outside of the box. So the first one actually was very fun, and let's say maybe not even traditional security CTF. It was called AI CTF. So it's something about AI, artificial intelligence, and machine learning specifics. So being a huge fan and practitioner of ML, I was like, immediately, I really want to go and do these kind of things. It should be very much fun. So here is the link, and on the link you could find like the whole blog about what was there and how to solve the problems. I'm gonna just talk about something we as a team was trying to solve. And once again, was just doing it by myself. I was having a teammate, Sergey. So Sergey was helping me greatly. And thanks for participating. And I hope next year or this year, if they're gonna have another AI CTF, we're gonna do a dream team again. So the first one is actually quite fun, related to, let's say, some sort of automation. So very often, another aspects of tasks is called sometimes like development, like professional development or professional coding services. So in this case, what was happening is there was some sort of web interface, REST API, basically, where by the post you could see the picture, and you would need to answer via the post if it's a cat or not. And initially it was looking like, very easy. You're thinking like, hey, I could just get a pre-built model or something and use it, right? Like there is tons of pre-built models available online, but I thought it was not as much fun. So I decided like, hey, what the hell? I'm gonna build my own model. So I used I think VGJ19, which is a state-of-the-art object detection model, and then I think I got a data set on the cats and dogs and basically trained it. And let's say and then writing, of course, the automation part of it. And most of the stuff was kind of like spot on. It was doing just fine, easy, detection, stuff like this. But then the pictures start becoming really crazy, and actually, I'm not sure if you're able to see those pictures on the screen, but some of them are very, very much straightforward. Like a cat, nice looking cat, nice looking dog. But then there is like images where cat is like really big or in conjunction with like humans' hands and stuff like this, and then the model of course starts really suffering in terms of performance. So I even like retrained or like learned the model after pre-training its initially, and then I was able to walk through. So basically it was like, I don't know, maybe hundreds of examples that you need to do in a short amount of time. It was quite fun, would say straightforward. Then there was the task basically called AlexNet, and for those who might know AlexNet or might not know, sorry, AlexNet is an architecture of convolutional neural network, CNN, and basically it's just 2.0, right? And it looks like there's some sort of new version or something. And I didn't said about this one, but usually in the tasks they try to be like categorized. So there's a label around each of the tasks which says like which area of the problem it's going to. In this case, it was marked as Stigano. So once again, steganography. So and like I was looking into this model. I like loaded my Jupyter notebook or something. Then I just like did like the model eval, based on the model, and I see like different like sequential layers, convolutional, ReLU, max pooling, all these kind of things. So I was like, okay, so what's that? That looks like a normal. I think I even just double checked if the architecture is the same, and like it's like straightforward AlexNet, nothing new, nothing fancy. And then of course I was like different options what to do, and then I only realized like later, I think even after the competition, that you could actually plot like the weights, the layers, and actually plotting this. Usually there's just a useless kind of pictures, like like this one, like in different layers in different direction, because they need to pick up the important pieces of the images. But it was actually the first part where the flag was encoded, right? So, and I think very important to tell that usually each and every one competition is having some sort of own format of the flag. So first of all, it's sometimes a name of the competition. So in this case, it was the CTF. Then there is a curly braces, and then there is some text, which is actually like a flag, and then finishing by the closing curly braces. So today, actually, in our competition, we're gonna follow the same. We're gonna follow the same format. We're gonna have the name of the competition, which would be a Codeberry CTF, and then we're gonna have a curly braces and the flag inside it. So it was actually quite straightforward. I think as soon as you realize that you could plot the weights. Unfortunately, I don't think we were managed to solve this one on the competition. And there was like something called big data, and I think it was maybe Stigano as well. And it was basically like a huge CSV file with a lot of columns, right? So, and I was thinking like, what should be done? And when you think about as a data scientist, as a CSV, you think like, hey, I have a lot of data, a lot of columns. I need pandas, right? So pandas is amazing framework in Python that could help you massaging the data and do all of those sorts of things. So okay, you open like it's in the pandas, do the head, let's say, and you see just some values, there is some numbers, and there is a lot of like columns there, and the names are meaningless. I think initial one of the aspect was like, hey, let's try to find if the name's meaning anything, if it's encoded or something. Then I think we did like some sort of data analysis, like what's the average means, maybe something hidden there. But then I think Sergey was just basically spot on, thinking like, hey, let's maybe try to do a clusterization of those, right? Because basically what's at the end there is a lot of the data there, a lot of columns. It's multidimensional data, highly multidimensional data. And let's do some sort of clusterization. And actually the examples were looking pretty cool. You immediately realize that, hey, this is not normal clusterization, right? Because usually during the clusterization, you would have any sorts of more like a dots, which would be more sprayed out, and obviously the clusters of it. So I was like, okay, that looks very much interesting. And I think organizers even use our picture in their write-ups, showing how beautiful this could be. And I think we were drawing this one or clusterizing like via TSNE or k-means and different other algorithms, and they really have a nice pictures. But still not clear what's the flag would be, right? Especially knowing that the format of the flag is something like AI CTF. And then, we weren't able to actually solve it. What it turns out, it was that we used a different wrong clusterization technique. What is supposed actually to do is, if you do the PCA, like principal component analysis, and then do some sort of manipulation, then actually it looks like a flag, right? So it's AI CTF. Now you are a true data scientist. So actually it was quite fun. Even though I was a bit disappointed that we're so close and our pictures were so nice, but they nowhere close to the actual flag. Okay, and this one, the last task, maybe not the last. I'm gonna maybe talk a little bit about other tasks as well, which was actually not from the AI CTF, but from the Russian Cup, CTF Russian Cup. And in this case, it was called PDF vulnerability. It was about PDF vulnerability. So basically, they were like saying, "Hey, we had a weird PDF, and nobody knows what to do with this. Could you give it a try?" And this is basically how PDF looks like when I open it. It was literally one empty page, right? And of course, in Stigana, when you're doing something like this, you immediately start looking into like metadata. Sometimes flag could be hidden metadata. Think about any other options. Maybe that's actually not a PDF, but something different, right? So you check in what's the actual content of the file. Maybe it just is displayed this way or something. Using like some default PDF viewers sometimes not helping, just because they are too much hiding errors from the users. Maybe we need to use some sort of custom one or some PDF SDK. I think we even spent time reading like PDF standard to understand it better, and like what's actually hidden inside the PDF. And actually, it turns out, right? So PDF is not just a piece of text, or like maybe like in docx file, like in Word documents when there is like sections, but still. What is actually PDF contains? It actually contains the streams of data and different types of objects. So actually, this is the output of one of the PDF reading tools, like a deep reading PDF tools. And actually, you could see here that there is like 6 objects and 1 stream. And then it starts to be really interesting, especially thinking that we only saw empty PDF page, right? There was nothing there. And then we looked like an encoded stream or something, and then there was like 6 objects. And interestingly enough, one of the objects is saying to be JavaScript and being some sort of CVE. It sees something like a number of CVE. So basically, this is the standard format of the vulnerability and vulnerability exploit. So idea was like, hey, let's take a look into those objects. Maybe some of the objects contain some data, right? And then like in one of the objects, in one of these JavaScript objects, I was able to find like the code like this. And this is actually like legitimately the code that was in the object, right? And really difficult to understand what it's doing, especially because it's clearly obfuscated, right? So you could see that actually the names of the variables are different. So then what it leads to is I was like, okay, we need to deobfuscate it, right? What's happening? Like what's going on, right? Like so like I rename it to be more proper, shorter names. Then I started looking, and basically it's like some sort of cycles, iterations, and then basically unescaping different UTF symbols. And then it was like actually completely unclear, like what's actually happening. And then I was taking a look. Okay, there was a CVE mentioned, like maybe CVE is related to something. And actually, CVE was about ability to execute the code in PDF document, but not just JavaScript code, because what was there? Because JavaScript is usually executed in the sandbox, and executing in the sandbox is quite difficult. You don't have much of the permissions to do, only maybe if you have some sort of vulnerabilities. But in fact, what was actually happening, this vulnerability, this CVE, was more about that they could overflow the buffer. And overflowing the buffer could provide the ability actually to execute the code and execute outside of the sandbox. So the idea was to actually find like what's this binary file and where it's hidden actually. And yeah, basically then I was realizing that these symbols. Sorry, let me go back. These symbols, these UTF symbols, they're not just something, right? Because initially, if you look into these UTF symbols, they're just Asian symbols, Asian alphabet symbols, I think, and they don't have any sort of meaning or something. But thinking more and more about CV, I realized, okay, maybe these are just used to overflow the buffer, but only the last part, the important part, what is important. So yeah, so then I wrote a simple Python script basically where I was like reading the file, and reading the file, I was able to write these unescaped things, unencoded them, translate this to the binary, and actually save it to the binary file. And then, of course, it was only interesting to see actually what's this shell file is doing, and actually like the advice for everybody who's doing CTF, especially like the serious CTF, whenever you do the CTF, you don't have to do. No, sorry. I would say it differently. You shouldn't do this on your like work machine or like personal machine. I would rather recommend to use like some sort of virtual machines, like virtual images. Very often, like Kali Linux, for example, is very much recommended. But I think the most important thing is like you need to have something which you could just drop, erase, terminate, and forget about it, because you never know what kind of shells or what kind of vulnerabilities you're going to find. So in this case, as soon as I realized I got a binary, it's still not clear, right? I still didn't find the flag. And then I didn't want to run it because I think at the time I didn't have my VirtualBox environment being set up or something. I think it was somewhere in the middle. So there's a special like shellcode testing utility, which provides you ability to test the binary but not execute it. So you could see like what actually is happening there. And this is what I actually did with the SC test. And yeah, you could see that there is like some sort of Windows API execution, and yeah, like you could see some process here. I'm not even sure I understand all of this because it's like Windows API, with some D words and stuff like this. But what you could see actually, that you could see the flag here inside. So this is in the string, and this is what the flag was. So cap, you have been pound, is actually the flag that you would need to submit. And yeah, submitting was quite fun to do. As long as you get this nice feeling that you are able to complete something, you complete the task. It's actually very much rewarding. To be honest, this is pretty much close to the end of the discussion of today's presentation, at least. I want to stop here just for a second and say that all pictures that have been used in the presentation and are done, created by this person, Simon Stellenhag. This is the person from Sweden, and I really love his works. That's why I use them in the presentation. So yeah, I would recommend, if you like this steampunk, technopunk kind of images to go there and check it out. I think they even had Amazon Prime series done inspired by these pictures. Anyway, so yeah, so this is it for today. We're gonna have some sort of Q&A, and then the competition gonna start. So let me double check if you have any questions.
We have one question. Will it be a team competition?
To be honest, we didn't specify this to be like team versus team. I would recommend to do this by ourselves, by one person, just because the tasks are much simpler, and let's say they're generally much simpler than happening on the like proper competitions. So I think with this competition, we're rather trying to start this series of competitions. And today they are much more simple. I would recommend to just solve it on your own.
Okay, thank you for the answer. Let's move to the tasks.
Yeah, basically what we have here. So we have a special Telegram bot, basically, where you could specify any sorts of commands, and help command gonna just show about the tasks that needs to be challenges that needs to be solved. There would be a start command which would be explained there as well, and there would be a status board which would basically say what's the current place, how many flags you solved. And to solve the flag, we're using completely Telegram oriented competition today. You just need to send the message to the bot with the actual flag, and if it's correct flag, you're gonna get accepted, and that's it. I think we could have like a feedbacks or anything like this, or if something is not working maybe for you, or some system might be down. In this case, you could use our Codeberry Club Telegram chat, and basically post your questions here to myself or Andrei, and I think we will try to answer them as soon as possible.
Yeah, feel free to put any questions in our chat in Telegram. I will put links to the board to the chat under the video. Also, if you already read our channel, I put this information to channel as well.
Awesome. Thank you, Andrei. So yeah.
So good luck, and we will gather together on Monday and talk about results and about winners.
And about solutions as well.
Yeah, it will be interesting. Also, I'm going to notify that every winner will get T-shirt with Codeberry Club logo.
Sounds great.
So I think that's it for today. Any questions, suggestions, feel free to put in our channels, and good luck and have a good weekend.
Thank you. Bye.
Bye.